essentials. Address them later at the Q&A session. For the StackLeague overview, before we dive into tonight's session, we would like to give you an overview of StackLeague. King Bartolome of StackLeague will help me with that. Take it away, King.
Okay, so thank you, Carl, for introducing me. Okay, good evening again, everyone. Again, I am King, and I will be giving you an overview of Stack League, especially if it's your first time to join a Stack League event. All right, so let's move forward. So Stack League is the Philippines' largest programming competition or programming league. Our mission is to develop programming leaders to inspire the nation into coding. So the tournament is powered by StackTrek's fully automated talent analytics and assessment platform. Now that the Stack League is in its second competitive year, Stack League wouldn't be possible without the support of our partners, and we're very fortunate enough to be supported by the top companies in the industry. So we have silver sponsor, the Coding Chiefs. We also have bronze sponsors, the Microsoft, Dell Tech Systems, Upper.ph, Recruit Day, and Gcash. And also our media partners, Spark Up, Apps Gadget, Was Up Pilipinas, Corner Magazine PH, Android Disc, Megabytes, Backend News, Blue Wing, and Manila Republic. And also, the same goes for our community partners who help the league reach as many programmers in the country as possible. So here they are. Okay, so the Pioneering Programming League was launched last year of March 16, 2021, and is now gathering over 10,000 tech talents across the country. So that's so much or very many tech talents that is competing with each other. And of course, since it's a competition, they will be receiving prizes that they can leverage. First, we are testing their leadership, their perseverance, and their coding skills with the promise of nationwide media recognition, thousands of tech job opportunities, and access to invitation only events. And just to share with you guys, the league's year-round cash prize pool is now at 10 million pesos in the duration of the whole competition. Okay, so moving forward, one of the highlights of Stack League is the weekly stack race for both individual and team categories. So each week, the top 10 challengers and the top 3 teams are announced all across the Stack League social media platforms, and it would be to recognize all of the challengers who stayed on top of the rankings. So apart from this one, we also have the Stack League feature programmer and team campaign. So the weekly top 10 challengers and top 3 teams are going to be featured on our Stack League's website or Stack League website and on our social media platforms. Stack League will also be hosting numerous tech sessions and career sessions all throughout the year. And aside from this, we also have exclusive trainings available for ranking up to the next challenger level. So these events and trainings are all for free for as long as you're part of the Stack League community or you are a member of Stack League. Okay, so now we also have the Stack League Ambassador Program. It is a year-round initiative so that we would be able to reward Stack League challengers who go beyond the competition and inspire the nation into coding. So to tell you more about the Stack League Ambassador Program, here is a short clip for you to see. All right, so congratulations to Jeremiah Daniel Regalario for being the Stack League ambassador for the month of May. So winning the prize of 3,000 pesos and a Stack League t-shirt. So if you want to be the next Stack League ambassador and win the cash prize and t-shirt, all you have to do is the program for the month of June is now open. So you can find the full mechanics at our website, bit.ly/Stack League Ambassador 2022. Okay, so moving forward, we also have for the ranking system and our initial competition. So for the programming languages that are supported in the league, we have JavaScript, Java, Python, C Sharp, and PHP. And for the ranking system, this is how it works. So basically, when you sign up, you will start at the bottom with 0 points. And after signing up, all you have to do is solve as many challenges as you can, and you will earn corresponding points. So the more points you earn, the higher your ranking goes. And once you have accumulated enough points, you can now get to the next level challenges where more opportunities are unlocked for you to access. So there are three challenger levels. We have bronze, silver, and gold. So this year, the new thing for the players would be the challenger level of prizes. So once you unlock the bronze level, you will receive 100 pesos. Same goes with the silver. So once you unlock the silver level, you will also receive 100 pesos. And to unlock the gold level, you will receive 300 pesos for a total of 500 pesos. Okay, so there's also the Stack League Treasure Chest individual category. So wherein the weekly top 10 receive or the weekly top 10 challengers will be receiving 500 pesos each as a cash prize. We also have the Stack League Playoffs. The Stack League Playoffs is a single elimination tournament featuring all monthly qualifiers, um, where all weekly top 10 Stack League challengers will be automatically invited to the monthly qualifier rounds. So you can read the full mechanics at bit.ly/Stack League Playoffs 2022. So to know more about the Stack League Playoffs, here is another clip for you to watch. Okay, so lastly, if you're interested in testing your skill in time-bound programming competition, such as Stack League playoffs but couldn't get to the weekly top 10, the Lightning Series is open to all non-gold level challengers. So you can find the mechanics at bit.ly/Lightning Series mechanics, and the schedule for the month of June has been posted. So please take note, you will be receiving an email for the invitation. And I think that's it for the overview of Stack League. And remember that as a year-round competition or a year-round tournament, Stack League is looking for the best challengers that can stay up in the ranks and become programming leaders for the long haul. That's all on my end. Back to you, Carl.
Thank you, King, for giving a short introduction of StackLeague. Let's not delay any further. Our resource speaker has 6 years of experience as a software engineer for Java and web. He has also been a senior engineering manager for 2 years and cloud infrastructure engineer for another 2 years. Currently, he is a cloud infrastructure engineer or DevOps at MDI Novare. Let's give a warm welcome to Tristan Angelo Babasa.
Hello. So good afternoon or good evening, everyone. No? So uh, just to add more information lang out of my experience. No? So basically, I'm still a developer right now. No? So I've been working for at least 12 years. So I have seen the industry change from 10, like 12 years ago until today. So that's why this topic is really essential. No, like uh, how it was years ago and how it has improved today, and why is it important for us to learn uh, these new skills now for like for containerization. So just some prerequisites uh, on the audience, so that you'll be able to at least understand and appreciate more of this topic is at least you, at least you know at least a programming language and have already built an application and already is deploying your application to whatever environment you're uh, targeting now. So this is for those people. Okay, so just to start now, so this one is Docker Essential. So for this session, what is our agenda? So let me just So by the end of the session, so you'll be able to know like what is Docker, and then to be able to understand it fully, we have to understand the difference between a virtual machine and the containers because they're quite similar. And of course, an architecture of Docker and how do you install your Docker? How do you install the Docker service to your local machine? And of course, understand what will change in your development workflow. So, if your team is not yet using Docker, so most likely there'll be not really a big change, but it's an improvement in your development workflow. So hopefully this will supplement your current development workflow. Okay. So what is Docker? So it is a platform for building, running, and shipping applications. No, so it's not a programming language, but it will help you build it, run it, and ship it efficiently. Okay. So it primarily solves this problem. This is a very famous problem ever since until now. No, it's even though already using Docker, sometimes it's this still pops up. So it works on machines. If you're working with your QA, this is the famous excuse. No, so why does this happen? No, so these are some key reasons. No, like sometimes there are some missing files. No, like it's not included in your Git repository, like configuration files, which are uh, like if you're deploying on a different environment, and then yeah, most may contain neglect lang. So yeah, so you miss files like config files. Next, of course, you must software version mismatch, especially if you're using like a Python, Node.js, your packages natin, even for Java, uh, on different environments. Usually, you the way we deploy things without Docker is usually provide like a release note, a deployment plan. So like install this version of Java, install this Python version, install uh, a pip install, and like a MySQL client version. So and it's very difficult to debug, because it's not in the code. Next, yeah, so it's quite similar with the first one. No? So different configuration settings, especially if you're using environment variables, application properties. So because most developers don't really uh, mind much on how it is deployed in production. So usually you have a separate person to handle this, and that a separate person usually it's not informed. So this one's one of the key reasons. Okay, so what does Docker do? No? So in Docker, we can easily package our application with everything that it needs and run it everywhere and any machine. So for example, this one, we have a Node 14 version, and then let's say your Node application uses a Postgre version 9.6, and then your actual application. So it packages it to uh, this one. Now we can take this package and run it anywhere that runs Docker or any container technology. When I say container technology, because Docker usually is it's a brand name now. It's like Colgate. So, but Docker is still the most used and most easily available documentation. But the common term should be containers. Okay, so I'll be interchanging these terms later. Okay, so another advantage of using Docker now. So for example, if you have a you already have a team, for example, uh, it's if you don't have documentation in your current team, it's very hard to onboard developers on how you're gonna run the application, especially if your application is already quite large. It's a legacy application. There's lots of configuration. If you're using microservices, it's possibly a combination of 10 applications. Uh, so it's quite difficult to uh, teach like run this, and then run this version of MySQL, run this version. So this solves that problem. Okay. And then so that they don't have to configure or install all the dependencies. It's the configuration will be written on a Docker configuration file. Okay. So usually when you have a new deployment team and a new developer, they only have to understand this command, no, like docker run, and then it'll run the application. So no more configuration. Not saying it's fully no configuration at all, but you will have a standard command list to be able to run your applications. I don't have to like how do you run a Node application? How do you run a Python application? How do you run a Java application? So as a deployment engineer, I won't have to think about those things. I only have to think about Docker run, and I should be good to go. Okay. Next, so this one's a sample of like two isolated environments. This is a common scenario. Like for example, one container may have this version of Node, while the other version, the other container has this version. So possibly this node is like a legacy system, but but your mobile application needs these two. No, so it's quite difficult to run this on a single machine because of course, how do you switch the version? So this is a common scenario where two applications where you need to have different versions of applications. Okay. Uh, and also, like for example, if you don't need this version, for example, Node 9, like this one's a legacy, we don't need it anymore, and it's installed in your machine. So it's quite easy to remove. You just delete the container, and then it will be gone. So in a nutshell, no, the Docker allows to consistently build, run, and ship your applications. So this is quite important in consistency when you build because it really this your company, for example, if your application reputation really depends on the quality and then if your quality of your releases. So this solves that one. Uh, so as a developer or even a DevOps engineer, so it seems like a must learn skill. No? So when I say developers and DevOps, they usually work hand in hand. No? So the DevOps engineer will help you uh, lift your application to any environments, but the developer still needs to give instructions on how to build your application. So they have to work hand in hand. Okay, so now we have to discuss to fully understand containers. We have to see how it evolved from way back. So we have to differentiate virtual machines as what's the difference with containers. So a container is an isolated environment for running an application. A virtual machine is an abstraction of a machine. No, so it has to have a physical hardware. So if you're familiar with virtual machines, diba, like if you're using VMware or what do you call this, Oracle VM. Uh, so those are the types. Those are virtual machines. So this is a typical virtual machine setup. Like for one machine, you have for example, you have a Mac OS running or even a Windows. And then if you want to have virtual machine for a Windows machine and a Linux machine, one layer that you need is a hypervisor. So this is just some additional info for those who doesn't care what's a hypervisor. So hyper just to help you understand that there is this abstraction. The hypervisor is technically this one. So you have your virtual box, your VMware, and your Hyper-V. So this is the one that helps you like compartmentalize your physical machine to cater to different OSs. No? So yeah. So if some people ask what is a hypervisor, technically these are just the virtual box, VMware, and Hyper-V. Okay, so this is a typical virtual machine setup. So like 7 years before, when virtual machines was still hip. This is typically your current setup. Like if you have an infrastructure team that or even AWS instance, so you provision a virtual machine and then you install uh, your application, the necessary Java version, for example, in the database. Similar with your next application, no? So up to let's say you wanted to use a different Java version for some reason, and then a later version of Mongo 3 since you're comfortable to a lower version. So it depends upon you. So this is a typical setup. This is for isolation. So the problem with this setup is each VM needs a full-blown OS. So you have to install, for example, if you wanted Ubuntu or CentOS for the machine, so you have to install the CentOS. Now, if it's a physical virtual machine, and then if it's a cloud uh, virtual machine, usually you have to choose an OS also. So, and then of course, it's very slow to start up. So it's a full-blown OS. It's like booting your local machine, and then it's resource intensive because one instance of the virtual machine under a one physical machine, you have to provision, like for example, 8 gigs of RAM, like a 500 gigabyte SSD. So it's quite just to run this one application. Yeah, so it's very resource intensive. Now, what is containers? Now, containers allows allows running multiple apps in app isolation. So it's quite similar to a virtual machine, but it is rather lightweight. Okay, and it uses already the OS the OS of the host that it is like riding on. And since the OS is already started up, so it starts quickly. It doesn't really need to boot up the OS anymore. And then, of course, since you're only sharing resources with the already provisioned virtual machine, it doesn't need that much resources as well. Okay. Uh, Sorry. This is a typical setup for Docker setup on your local machine. So when you install Docker, you have what you call a Docker engine that will interpret all your Docker commands. So it will provide a REST API for your Docker client. So this one's your command line. This is your command line interface to call any Docker features. No? So one prerequisite also for uh, one prerequisite for using Docker is you also have to learn to use the command line. No? So although Docker has its own some, like for Docker in Mac and Windows, they provide a UI for managing your Docker images or Docker containers, but it is still essential to know your command line interface. Okay. So also one thing to know when you're using Docker. So for example, if you're running a Windows machine, the you in a Docker container, you also have to provide what OS should it be running. Okay, so for example, for Node, if your container wants to use uh, Ubuntu, you have to choose a machine that can run Linux instances. For example, for Windows, you can use container images that is like for example a Linux in a Windows, because Windows 10 right now can run Linux OSs, since the kernel can run Linux commands right now. So it the container technically uses the kernel of the host machine. So for a Linux machine, for this one, if you're using Ubuntu, any Ubuntu or Linux OS, you can only run Linux flavored containers also. No, so for example, if you want to run on a Windows server, you cannot run a Windows container on a Linux machine. So that's something nice to know. No, or you cannot run the Windows server on a Mac machine as well. But almost all Linux OSs can be run on all platforms. Okay. So this is a typical setup for in comparison when you're using a virtual machine as compared to a Docker setup. So on a virtual machine, so this was the hypervisor, and then you have your virtual machine plus the OS, then before the application. So you can already imagine how bloated or resource intensive when you're using your typical setup ng virtual machine. Whereas if you're running Docker on a single virtual machine, you will be sharing your operating system like this one, and then you just have your like standard library packages, and then your actual application. Okay, so when you say packages, like for example, if you want to install I don't know, JS, Java version, so that's the packages before installing the application. It's still isolated, but it's very lightweight. So that's why the kernel the kernel is important because the OS that the container will be using is the operating system. No. Okay, so this one is just to teach you how to install Docker on your system. So it's quite easy, no? So you just have to Google get Docker just here. So it already provides you with different if you're using a Mac or Windows in a or a Linux machine. So you just have to follow the instruction. And by the end of this, if you install the your Docker service, you just have to make sure that it is running. So for me, I have a uh, UI here that says my Docker is already running on my machine. Okay. So now, for the most important part now, what will change on your current workflow? Okay, so this is the usual development setup. So you have your application, for example, if you're a Python or a Node.js, you have your uh, files, no? So JS files uh, or Java files. What you need to add? Just wait. What the only thing you have to add is this Docker file. So the Docker file contains all the instructions on how to build and run your application. So, so take note that build and run. So that it means that the developer or possibly your DevOps engineer can help you uh, build the Docker file because the developers usually knows how to build the application. They know the configurations, so they have to craft the Docker file, which will then be built into an image. So you have to imagine the image as a virtual machine. So it's like a virtual machine you can export like to the appliance and then use it somewhere else. Okay. So all the setup should be already be in the image. No, so when you run the image, there shouldn't be any more additional setup on how to build and run your application. Now, what is the image naman? So the image, when you build the Docker image, it is a cut down OS. No, so it has an OS, but it is trimmed to be like just the kernel of the OS. No, it will still use the host OS, but it has this technique like it has namespaces that partitions your application to the actual kernel, for example, something like that. Uh, you need to provide a runtime. So runtime, if it's run, it should be running. The application should be running a Node, Java. So you can pre-install when you build the application, and then you also provide the application files. So application files, your JS files, your JavaScript files, your jar files. So you can put it there, and then if you're using any third-party libraries, you have to declare what third-party libraries you need. For example, if you want to have, for example, of Python, you usually install a MySQL client. So you have to install those. And then you can also provide environment variables because since we'll be deploying in multiple environments, for example, if you have a development environment, you have a UAT environment, and then you have your production environment, you have to make it configurable. Okay, so usually they have different, like for example, database connections. It's different on different environments. So you have to build your application to either use the environment variable, or there's also a way to override the application or properties file. There's also a way to do that. Okay, so basically, when you have your image, so you the way to run your image is to place it in a container. No, so the image is not yet the container. So when you do a Docker run, uh, the image is run like a process. No, it's not similar to how you run a virtual machine where you have to boot, but it treats it treats your application as a process. It's like a similar application process in your OS. Okay, so That one is important to know. Next one. So this one is one of the beauty of using Docker now. So how do you what will change in how you deploy your application? So usually uh, when you build your application on the development environment, you have your image, and how do you ship it to the production? Usually you push your image to a registry. Okay, so when we say a registry, it's like it's like a Git a repository of your code. So you can push your image to a repository, and then your test environment or production environment can pull that image and then run it in application. So since there's no like in between guy to configure this, so it makes sure that the image you're pushing to the container registry is the same image that is run on the environment. Okay, so that gives you the consistency in your application, no, when you're deploying it. Okay, so let's go to the fun part now. So let's try doing a actual demo now. So right now, so to make things quick now, so I already prepared some projects. So let's start with. Can we zoom in? Is it zoom in? Yeah. Let's make it bigger. Wait. So I created this project like it contains it is just log. No, so it's a script. So it's a typical Node application. So usually, what do you need to know? Like how do you run the applications? So it's just a simple node that applicates command, and then you have your application run. Now, let's say this is already your no. Let's imagine that this is already a big application. Uh, how do you Dockerize? So what we need is just to add this Docker file. The Docker file contains this elements node. First is the from. So it says here node alpine. So this one is the image, the base image that is run. Alpine is it's based on I forgot what Linux flavor it is. Just imagine it's like Ubuntu or CentOS, but it is called Alpine. So Alpine is like a very lightweight Linux machine, and then Node is like it's like a Linux with a Node environment. So it's like installed uh, Node application. Yeah, okay. So what we need to do, you just copy the the files. So let's see. Just copy the files in the container, the image, and then I copy all the files to a directory called /application, and then switch to that application, and then run the command node app.js. So this is the instructions to build and then run the applications. Okay, so how do you build the image? So this command. So don't like memorize what I'm typing. It's all of these are available online on the commands when you try to search it. What's important is if it's really helpful in your development cycle. Okay, so Docker build, and then let's give it a uh, name. So let's give it a name like hello, and then just then provide the location on where the Docker file is located. Is Docker directory, which is dot. Okay, so once built, you can use the Docker images command to see the built images. Right now, the built image is found here. So you can see uh, this one. Hello. And then how do you run this one? So you just do a Docker run, and then docker run, and then the image name, and then you have to provide which version, which is the tag here. So if you don't provide a version here, uh, it'll use the latest tag. So just to demo, if you want to provide a version, you can place like 1.0.0. If you check, there will be another image with a version 1.0.0. So it's just labeling. So if doing tag, or tagging is technically versioning. Okay, so if you want to run, you can use the docker run hello, and then provide the version you want to run or the latest. Should be okay. So it does the same thing. So it runs uh, Docker. Okay, so that's very simplistic now. So let's go to a much more uh, in a bigger application. So this one is still a node application. Let me just check. No, not this one. This one, Docker node. So this one I have a much bigger application. So what's inside? So this one's an Express JS. So it's a REST endpoint. Okay, so it's a web. It'll just return an HTML, but uh, it'll host a server running on port 8080 on a local host machine. So what to do next? So we also have the package.json so that you will know what to install for those Node developers out there. So you're quite familiar naman with this one. Now, what are the steps to run? No, so first thing is I have to do the npm install. So once that's done, we can run like node server.js. It's running on 8080. So can we do with this? Localhost running 8080. So this one. So hello stack. Very simple. Now let's try to understand the Docker file. So this one, I'm using a different image because I copy pasted this one. So it's running a node 14. I believe this is running on an Ubuntu machine. And then we created a working directory to where we want to place the node application, and then copy the package.json file so that we know what to build, no, and then run the npm install. So this part is the build phase. And then after that, after building the application, you can uh, bundle up the resources, expose a port, because you have to imagine that this is a virtual machine. It has a closed network by default. So you have to expose a port so that it can be accessed outside. Okay, so once that's done, so we can build this one, Docker build. Same, let's give it a tag. Let's say hello node server. Give it a version, then the location of the file. Similarly, we have the images here. So this one's the one we built right now. Docker hello node server. And then how do we run this one? So we have a command called, since this is a web application, we have to expose some ports also. Uh, I'm gonna run this in a detached mode. So if you're not familiar with what I'm the commands I'm using, you can use the help command to see what I'm doing. So I want to use the detached mode so that when I run the application, I don't like it's running in the background. Okay, so that's detached. So Docker run -d. I forgot the images. Let me just run this again. Docker run -d -p, which is the port. So for this one, we have to specify which port should be out. You're gonna expose, and which port inside. So this one's a routing. So since it's gonna on the container, it's an 8080. We can choose to reroute the port to another port like this one, 8082. Okay, and then run your application. Let's say 1.0.0. Let's see, hope for the best. So it will give you this container ID. You can see the running Docker images using Docker PS. So like I said earlier, this is a process. So this one's the one running. And then you can look at the logs using the Docker logs command, and then you follow. As you see, it's also running in 8080. But since we rerouted it to 8082, so we can access it in port 8082. So it's the same. So you can imagine, like, if you see, it's really entering here. So I have a log high. Also, you can see the benefits. No, so let's say if you have like 10 applications, 10 APIs running on a single machine, and for by example, for by chance, you're also all using port 8080. So you have the way to change the port is you have to edit the properties file, you have to edit the code, and then right. So which is cumbersome. So in this way, you can control the port it's gonna use. No, so on your projects when it is run. Okay, so that's one way. And also, you can also check what's happening inside. So you have to imagine that this is also a virtual machine. No, so if you want to inspect what happened inside what on the image itself, we have a command called docker exec, and then I for interactive, and T for TTY. So TTY is like if you want to have a terminal-like experience when you do a SSH to the machine. So and then after giving the container ID, you can specify uh, this bash so that you can access the bash uh, terminal. So for this one, I'm already inside the session of the container. So if you check the files, so I have the files here. So since I copied everything naman on my local machine, so this is it. This is the structure. If you check the structure of the application, so it's basically a Linux machine. So you have to imagine that a container is technically just another virtual machine. Okay. I hope that is helpful. So what else can we do? No? So we have your running applications. I think the next step is uh, how do you simulate your deployment environments? Okay, so we have the image. Then what we need is a repository. So I suggest as a beginner, you can go back. You can use this one, which is Docker Hub. This is the default container repository, container registry. So you can create an account. It's free, and then you can create a repository here where you can push your images, and then we can later I'll show you how to simulate to deploy to a different environment. Okay, so right now you have these images here. No, so what's the requirement to push is you have to once you create a repository. Let's try to create a repository. Let's say StackLeague. StackLeague repo. So we have this sort of URL. So it's this is my account name, and then just your project name. So let's just copy here. In order to push there, we have to tag our application to that repository. So to do that, you can rename existing applications like Docker tag. So let's say we want to this one, the one we deployed earlier. Let's rename this one to about with my account name, and then StackLeague. Then the version. Spelling correct? Yes. So Docker tag. We do another Docker image. So we have this one. It's renamed. Now, so before we can push, you have to first log in. So by default, if you do a Docker login, it will log into Docker Hub. But you can also provide if you have your own repository, like I think GitHub provides one, AWS provides a repository, Azure has its own repository. So if you have in your like a company or your project team, if you want to host it other than Docker Hub, you can provide a parameter. So there is a command you can provide the server, the Docker login and the server. So you can have a target container registry. But if you don't provide the server, it will be default to Docker Hub. Okay. So let's try to push Docker images, Docker push, StackLeague. Sorry, I have to provide the version 1.0. So this will be pushing the images. I see there's no questions yet, no? So I'm checking. No. Okay. So this will take a while because it will push the whole image. No. So I'm just gonna assume that this will. Let's just fast track this one. Just another info. So you can see here the hash. This actually represents the layers. No. So what some parts present the OS. No. So if the OS doesn't exist yet in the registry, it will push it. If it already exists, it will reuse that existing. So that's how efficient the storage for uh, Docker when you're using Docker. Okay, so let's just try. I already pushed some builds here. Let's just reuse this one because I already knew it's gonna take a while to push. So let's say this one. So I want to deploy this pre-built application. Uh, you can use I have this lab environment now. So it's provided in the slides. So it's called labs that play with Docker. So this one provides you a practice VM for Docker. So this will simulate a different environment than rather than my local machine. So if you check Docker images, so this one is empty. So right now let's try to pull images from the repository. Docker Docker pull. I believe we have a latest version there. So you can pull the Docker image from the Docker Hub and then just run it here. So I don't have to like install Node.js on my machine. So we have a question. Yes, Kenny James. Yes, you can do any programming language with Docker. So that's its advantage. So from from based from the Docker file, you just have to find a base image. Like if you're used to using Ubuntu or Windows, that can be possible. But note, if you're using Windows, it can only be run in a Windows machine. Okay, so you have to consider those things. Even scripting, yeah, like Bash script, you can run it. So you have to treat containers as virtual machines also. Okay. So we have. Hope I answered your question, James. So we have your Docker images here. So we can run same way. Docker run dash p ap one latest looks host version. Wait. What version? Sorry, it's latest. Yes, Docker run. Mm-hmm. Does not match the host platform. Oh, okay. So it's probably a different image. Let's try. Is it done? Yes, this one's done. Let's try na lang this one pala. Let's, Docker pull. Then docker run dash p 80. Let's do 80 also. And then I want it to run detached. And weblogs slash stack league version 1.0.0. Specific platform. Wait, how come it's not running? Dash p. To double check. Docker run. There, it's okay. May mali ako. So this one was able to run. So you can do a docker ps, and then is this a script? Sorry. I think something went wrong. Let's not run it detached. I tried this yesterday. So I'm sorry, we're kind of out of time, but we can assume. I think I have some trouble with the Linux version right now. But we can assume that this is just an OS issue. But I assure you, this will run on a different machine. Okay, I don't have time to debug right now. But any more questions? Hopefully this helps on your in your application. So this kinds of ends the the demo. So most likely this will also run, but I can't debug right now. We're out of time. Platform detected host platform. It's probably the Linux version of this machine does not match. Okay. Do we have a question? Okay, so just to conclude, so these are my reference documents. No? So this one's really helpful when understanding this container training. This has a complete slides, yung container the training intro full day, and then of course yung main Docker website. And then the playground I'm using, it's the labs playwithdocker.com. So those are the resources. So hopefully this helps in your projects. Yes, yes, Kenny. It's gonna be. It's not that hard. It takes a while to understand everything, no? But once you understand uh, it fully, like if you imagine that it's just a virtual machine, it's quite easy to understand. The next step is just to memorizing the Docker commands, and like how do you build the Docker file, which is which is most likely already fully documented. It has been available for quite a while na rin. For this one, like for example, what does a work directory do? What does a copy do? So expose. So once you're already used to using this command, it's quite easy to transition. Of course, it will be additional. It will be additional task for a developer, but it's gonna be just a one-time task. So once you already created the Docker file, it's not gonna change drastically every time you deploy your application. Okay, so questions. Is there any platform we can learn where we can learn and practice? Yeah, I think I have the link. Let me see if I can copy paste it. This one's really helpful. Hey, copy. Actually, I can send this one. No? Like can we send hello admins? Can we send like text, or can I just share the slide later? Unfortunately, I can't send send this one. No? So we can probably send it separately. Okay, next, can you start that Docker images upon system startup? Can you start? Yes, you can. You can. Ano naman? Technically, you can. Uh, for example, when you start up your OS, of course you have to place it, for example, in a Linux machine. You init.d, you enable the Docker, and then of course you can run custom scripts to run your Docker applications. No, so it's just if you, for example, if you create a bash script to just to Docker run, and so the good thing about that is the one creating the script doesn't have to understand the programming language. No, so it's because on how it's going to be run is already going to be built by the developers. Okay. Do you highly recommend using Docker on the onset of app development? I think from the start, it can be added from on the at the end when you're gonna deploy it. But at least on your initial deployment, like for example in the development environment, we recommend already using Docker so that you'll be you'll be able to also build your application with the context that's gonna be built in Docker, because it's gonna change. Like for example, how do you provide the configuration files? Now, do you want to use environment variables? Do you still want to use your properties file? Because that's gonna influence how you're gonna deploy your Docker application. No, so it's gonna not influence very drastically, but it'll help easily help the DevOps team uh, deploy your application. Okay, and of course, using Docker, it's quite already supported by most, like for example, cloud environments now. Like for example, AWS has ECS, Elastic Container Service, which allows Dockers to be deployed directly. No, we have Kubernetes now, which is a quite different topic, which is purely using containers. And then of course we have I think HashiCorp when you're gonna use like Nomad. So it's all Docker based now. So if you want to scale, no, scale your application, and if you want to have a smaller team as well, Docker is the way to go now. Because when I say smaller team, like if you imagine if you're not using Docker, like your deployment team has to have, like for example, must at least know how to access virtual machines, must learn how to run Python, install packages. So it's difficult to find those people, no, because you don't usually use developers to deploy your applications. If you're already if you want to scale your application, so you have to different team to do your deployment. So if you have a standard using Docker, it's gonna be easy to translate to them now. So if they have Docker skills, then you just give them Docker images and they'll know what to do with it. Okay. So next is, will using Docker significantly cost less? We can't say how much, no. So it really depends. For example, if you're gonna purely use Docker on a scale, I don't recommend it. No, it's gonna be good only for like 1 to 4 applications. Because the problem Docker solves is more of on how you lift and shift your application to the cloud. No, it's not really cost savings, because if you want to have to really saving cost, you have to check muna, is my application gonna be used 24/7? So if it's an API, no, sabi kung 24 hours siyang ginagamit, siguro I can use yung AWS na ECS, no, so host ko doon yung Docker images instead of provisioning a virtual machine, and then lagay ko yung Docker if it's just one application, no. So if it's multiple, I can request kay AWS na one virtual machine, and then install install ko yung Docker images na 5, 'di ba? So we can also do that. So yung cost mo is just that cost of that virtual machine. Okay, so I can't really say how much, because it depends on how big your applications are, no. So like for example, I think one of the smallest images Docker virtual machines sa isa is like $50 per month. So if you can fit those applications, let's say if you can fit for Docker images na when you build yung application mo, parang kinakaya lang niya is 200 MB. So masusulit mo siya. So it depends on how big you ginagawa yung Docker. Also, there are also techniques on how to make your Docker application smaller. So if you notice here, Docker images, sorry, some images can be quite big, no? So kasi they have their base OS na hindi Alpine. For example, di ba example ni, yung Alpine image is quite small because it's a trimmed down OS. But their base OS like Ubuntu, it's a full blown OS also. It's quite big. So there are also ways to uh, trim down your applications. Like for example, I do have a live application. Uh, sorry, I have a Python project like it's here. For this one, it's one of my more complicated Docker file. So this one, I have a build phase, and then I provided an image for the build phase, and after I have the what do you call this build file, I remove all that. I remove all the what do you call this, like for example the libraries needed for building, because I won't be needing the libraries for building when it's already running, diba? So I have a build phase. So once after I built it, I remove the build libraries and just copy all the build file, and then that's the one I'm gonna run. So it's a technique where you can make it smaller, the Docker image also. And also one thing you have to consider is of course yung RAM, yung uh, how you using application. If it's highly like CPU intensive application, like for example a PHP application, it's gonna cost more because it's gonna use more CPU than yung RAM. Like for example, a Java is usually it's less CPU, and then more RAM. So the cost is not really on Docker, but on how you build your application as well. Here, disadvantages. Yeah, so disadvantages for Docker, when it's already quite large, no. So like for example, 10 applications, and then if you see how do you track, if you have this one, and how do you track the applications also. So it's not very good in orchestrating your applications. So it's quite hard to find, like if you have virtual machines and they have 5 Docker images running, it's quite hard to find which virtual machine was my application deployed. Okay, so it's not the strength of Docker to be on how it is managed. You usually have different tools for managing Docker, so that's where Kubernetes comes in. That's where ECS and Nomad, no. So those are other tools that can orchestrate your deployment for Docker. Okay, but Docker is the first step. No, if you want to have a scalable applications as well, and cost efficient consistency also in your builds. Okay, why Docker is the most used for documentation or containers? Yes, because the documentation is already available now. So the Docker file is already your documentation. If you notice here, it already documents how it's gonna be built and how it's gonna be run. So I don't have to provide like a deployment team, like a deployment guidelines or deployment plan anymore, because it's already built now. So what the deployment team has to do is just to Docker run the application. Na, hopefully I answer most. Meron pa ba? Okay. Hello, StackLeague team.
As much as we want to answer all your questions, that's it for our Q&A session. Before we dive into our announcements, is there anything else you want to add, Tristan?
Yeah, so just as closing, no? So hopefully if your team, let's say when you're gonna try to scale up, so Docker is not the it's just the baseline skill you need, no, because Docker itself is not very it's already easy, no, for abstracting yung most natin building and deployment, but there are other tools to also abstract yung how to make it even easier to use Docker, like for example Docker Compose, no. So that's one other skill you can add on once you finish Docker itself, no, because Docker Compose will help you manage more like the whole deployment itself. No, so Docker is just for building no, the application. And also, once you already learn Docker, it's quite easy to transition to like Kubernetes. Now, if you're gonna use that, or Node, or ECS, or even Azure. Azure also has a service for deploying Docker. So it's quite a standard also in the industry. So I believe it's a must skill no, for a scalable environment. Okay.
If you need
Yep.
more if you need more details, you can connect with Tristan after this session. Can you share with everyone, Tristan, how they can reach you?
Okay. This one I'm not prepared now. So you can reach me. I don't have a Facebook account. Uh, can reach me at this one na lang. At tristanbabasa@gmail.com. So how can I share text now? So can we share? This one I can chat pala. Sorry. So wait, can I just share the links? No. So for this one, I found nowhere to share this one, and then my email is here. Hopefully you don't spam me. Okay. There. Uh, I shared that as tactic yan, the private chat. I'm not sure how we're gonna share that info. Okay, so hopefully this session was helpful. No? Thanks, everyone.
Thank you to everyone for your questions, and thank you, Tristan, for answering our participants' questions, and of course, for that very insightful presentation. For the announcements, StackLeague Career Session. Kickstart a career as a freelance developer on June 16, Thursday at 6 p.m. For the StackLeague Sim Tech session, what you need to know about REST API and HTTP and build your first mobile app using React Native in 30 minutes on June 22, Wednesday at 6 p.m. We're almost halfway to the league. Join the league's StackLeague Mid-Year All-Stars on June 29, Wednesday at 6 p.m. to celebrate your breakthroughs and small wins. There will be pop quizzes, freebies, and giveaways. For the StackLeague session, journey from developer to manager on July 6, Wednesday at 6 p.m. For the StackLeague career session, how to land a successful job as a developer on July 13, Wednesday at 6 p.m. There are plenty of opportunities for you to learn here in StackLeague. Go to fb.com/StackLeague/events for the registration details and get the latest updates. To help the StackLeague team improve the sessions for you, answer this question form, bit.ly/StackLeague sessions feedback, or you can scan the QR code flash on your screen. StackLeague Ambassador for June is now accepting entries. To earn your ambassador points, you can either refer to friends and family or submit your blog sharing your league experience, or you can do both. Visit bit.ly/StackLeague Ambassador 2022 for more information. Also, make sure to earn league points to unlock the challenger levels and receive the prizes. Don't forget to also check out the StackLeague Lightning Series. Again, the schedule for the unranked category will be on June 14, Tuesday at 6 p.m. For more details, visit bit.ly/Lightning Series Mechanics. So that's all for the announcements. On behalf of the StackLeague team, I would like to say thank you to everybody for joining the StackLeague Tech Session Docker Essentials. If you don't have a StackLeague account yet, make sure to sign up now at stackleague.com, and of course, invite your friends and family who you think should be part of the league. See you guys at the next StackLeague event. This has been your host, Carl. Good night, everyone.